All right, so we're going to start applying the properties we've been learning about these special quadrilaterals into some math problems. So look at this first section. It is titled Parallelograms. And we're going to start by using the property that opposite sides are congruent in a parallelogram. So I know opposite sides are congruent. So if I'm looking to find AD, which is this side right here, I know that side AD is congruent to side BC. And since side BC equals 7, that means AD must also equal 7. Same thing for the other one. Now I'm looking for side AB, which is right here. I know side AB is congruent to side CD. And so since side CD equals 12, I can say AB also equals 12. Let's check out number 2. So I notice in number 2 I have some x's, so some variables. We want to solve for WK, but I do see a variable there, so I'm going to have to do some algebra. I know that side length WK is congruent to side length ZS. And since they're congruent, that means that their side lengths are equal. Therefore, I can say WK equals ZS and plug in what we know. We know WK is the expression x plus 3, and we know ZS equals 9. And now I'm going to solve this equation for x. So if I've got x plus 3 and I want to remove that plus 3, I want to move it to the other side of the equation, I'm going to subtract 3 from both sides. Because 3 minus 3 is 0, so I'm left with just x equals 9 minus 3 is 6. So now we've solved for x equals 6. And if I want to find WK, well, we know WK equals x plus 3. And now we know x is 6, so I can substitute in 6 for x. 6 plus 3 is 9. And that makes sense, right? That's what it should be because it's equal to ZS. Take a second and see if you can solve number 3. If you need some help, let's look at the setup for number 3. So if I see information about YE and HR, those are the two that I want to relate. Notice they are opposite sides, so that means they are congruent. So I can set their distances equal. So we know YE equals HR. Plug in what we know and solve for x. All right, so once you finish solving, let's go over this together. I'm going to plug in what I know. So I know YE is 2x plus 1. And I know HR is 3x minus 9. And now in order to solve this, I want to get all of my x's to one side and all of my numbers to the other. So if I want to move the x's, I'm going to always move the smaller x. That way I stay positive. So I've got a 2x here. I'm going to subtract 2x from each side. 2x minus 2x is 0, so I'll just bring down that positive 1. Equals 3x minus 2x is 1x. Remember, we don't have to write the 1 in front of it. And then I'll bring down that minus 9. So now I have 1 equals x minus 9. How do I move the minus 9 over? How am I going to get x by itself? In order to solve, I'm going to add 9 to both sides. So 1 plus 9 is 10. Bring down the x. Negative 9 plus 9 is 0. So we're left with x equals 10. So now we've solved for x, and we're going to use that to find HR. So we know that HR equals 3x minus 9. And now we know that x is 10. So now we can do 3 times 10 minus 9. And we're going to follow order of operations. So 3 times 10 is 30. Minus 9 is 21. So HR is 21. All right. In this next section, we're going to be looking at the property opposite angles are congruent. So I want to find the measure of angle G. That's right here. Angle G is opposite of angle E. So I know that those two angles are the two that are congruent. That means they must also be, their measures must be equal. So the measure of angle G must be 115 degrees. Let's look at number 5. So for number 5, I'm looking for the measure of angle R, which is right here. And that angle is opposite angle T. Let's set up our equation. I'm going to set them equal since they are congruent. So 3x plus 20 equals 110. I'm going to solve for x. The first thing I need to do is subtract the 20. I can't divide until I subtract the 20. So make sure you're very careful here. When we solve for a variable, so I'm trying to solve for x, get it by itself, I do an order of operations backwards. So the first thing I move is addition or subtraction. So when I subtract 20 from both sides, I get 3x equals 90. Now it's 3 times x, so to undo multiplication, we use division. Those are inverse operations. So I divide both sides by 3, and I get x equals 30. And so there's x. Now, we want to use that information to find the measure of angle R. So we know the measure of angle R equals 3x plus 20. And now we know that x is 30. So I plug it in. 3 times 30 plus 20. 3 times 30 is 90. Plus 20 is 110. So that's 110 degrees. And that matches what we need it to, right? Because it needs to be the same as angle T. All right, see if you can try number 6. At least get your setup and then unpause the video to go over the rest. So for this example, we're looking for angle P, which is right here, and it is opposite angle R. So I can set those two equal. So I'll say 11x plus 4 equals 9x plus 26. Now I'm going to solve for x. I want to get all of the x's to one side, and I'll start by moving the smaller x. So I'm going to subtract 9x from both sides. That way I stay with positive numbers. So 11x minus 9x is 2x. Bring down the plus 4 equals 26. The next thing I want to do, remember we do order of operations backwards when we're trying to move and solve for x. So to move over the 4, I'm going to subtract 4 from both sides. 2x equals 22. And now the inverse of multiplication is division. So I'm going to divide both sides by 2. And we get x equals 11. Now that I've found x, I want to find the measure of angle P. So the measure of angle P we know is represented by the expression 11x plus 4. Now I'm going to plug in 11 for x because that's what we just found. So 11 now times 11 plus 4. 11 times 11 is 121 plus 4 is 125. So the measure of angle P is 125 degrees. All right, in this next section, we're going to use the property that consecutive angles are supplementary. Remember, supplementary means that they sum to 180 degrees. So in number 7, I want to find the measure of angle H. Angle H is a consecutive angle with angle E because they are right next door to each other. That means that the measure of angle H plus the measure of angle E must equal 180 degrees because they are supplementary. So let's plug in what we know. We're looking for the measure of angle H, but we know that the measure of angle E is 115 degrees. And now we can solve for the measure of angle H by subtracting. So I'm going to subtract over 115. And when I do, I find that the measure of angle H equals 65 degrees. All right, in number 8, we are solving for the measure of angle Y. Now, in order to find the measure of angle Y, I need to solve for X first. So let's do that. We know that consecutive angles are supplementary. So the measure of angle Y plus the measure of angle U equals 180 degrees. Let's plug in what we know. We know that the measure of angle Y is represented by the expression 8x plus 8. And I know that the measure of angle U is 52, equal to 180. We want to simplify, so I've got here some like terms that we can add. On the left-hand side, we have 8 and 52, so I can add those. 8 plus 52 is 60, so we get 8x plus 60 equals 180. Then I can subtract over the 60, and I get 8x equals 120. Next, I want to divide both sides by 8, and we find that x equals 15. Now we're going to use that to solve for the measure of angle Y. So we know the measure of angle Y equals 8x plus 8. And I'm going to plug in. So we know that x is 15. So when I plug this in, 8 times 15 is 120, plus 8 is 128. If you want to double check, just do 128 plus 52 and make sure it equals 180. All right, you can try number 9 on your own, see what you can do. At the very least, see if you can set it up. If you're not feeling super confident, see if you could at least set up the equation. So we want to find the measure of angle W, which is consecutive with angle H. They're both next to each other, which means they are supplementary. So if I take the measure of angle H and I add the measure of angle W, it should equal 180 degrees. And so let's plug in what we know. I know the measure of angle H is 12x plus 15. I know the measure of angle W is 4x plus 5, and that equals 180 degrees. Now I want to combine like terms. Notice I have two x terms. We have a 12x and a 4x. So to combine those, I'm just going to add 12 plus 4, and I get 16x. The next like terms we have are the numbers. I have a positive 15 and a positive 5. When I add those together, I get positive 20. And that's equal to 180 still. Now I'm going to solve for x. And when we're solving, remember we do order of operations backwards. So the first thing that I need to deal with is that plus 20. So to cancel out a positive 20, we're going to use the inverse, which would be to subtract 20. So I subtract 20 from both sides, and I get 16x equals 160. Now, to get rid of the 16 in front of x, the inverse of multiplying by 16 would be to divide by 16. So I divide both sides by 16, and I get x equals 10. All right, so now let's use that to find the measure of angle W. So we know that the measure of angle W is represented by the expression 4x plus 5. So now let's plug in what we know. We know x equals 10. So now we get 4 times 10 plus 5. 4 times 10 is 40. Plus 5 is 45. So the measure of angle W is 45 degrees. All right, and the last of the properties specifically for parallelograms that we're going to look at is that the diagonals bisect each other. So looking at number 10, if the diagonals bisect each other, then I know that this line segment here, EA, is congruent to the other half of the diagonal from E to H. So since EA and EH are congruent, and we know EH is 5, then I also know that EA must be equal to 5. Well, the same thing happens on the other side. I know that EL is congruent to the other half of the diagonal, which is EW. And since EW is equal to 8, that means EL must also equal 8. All right, number 11. So now we're going to apply that same idea, but we've got some variables. So we're looking for MS, which is congruent to SA. These two pieces are congruent. Since they're congruent, we can set them equal. I can say 3x minus 7 equals 8. What should the length of MS be? Without even solving this, could we determine what it should be? We could, right? We could already say that it's going to be 8 because AS is 8. But we still need to solve for x, so let's keep working. When I solve this, the first thing I'm going to do is add 7 to both sides. And I get 3x equals 8 plus 7 is 15. Next, I'm going to divide both sides by 3. We get x equals 5. Now, we've already determined what MS equals, but it could be helpful just to double check our work. So I'm going to make sure that when I take 3x minus 7 and I plug in 5 for x, we indeed get 8. So 3 times 5 is 15, minus 7 is 8. So we did the check and we were right. Let's check out number 12. So in number 12, we first need to solve for x. I'm looking at NA, which is congruent to JA. Since they're congruent, I can set them equal. So we know JA equals AN. And I'm going to plug in what I know. So JA is 4x plus 2. And AN is 7x minus 13. And to solve these for x, I want to get all the x's to one side and all the numbers to the other. And so my strategy is always to move the x that is the smallest. So 4x is smaller than 7x, so I'll subtract 4x from both sides. 4x minus 4x is 0. Bring down the plus 2. 7x minus 4x is 3x, and I'll bring down the minus 13. Now, to continue solving this, the next thing I want to do is get rid of that minus 13, and the inverse would be 2 plus 13. Add 13 to both sides. 2 plus 13 is 15, which equals 3x. All right, the next thing that we want to do is get rid of the 3 in front of the x. To undo multiplication, we divide. So 15 divided by 3 is 5. 3 divided by 3 leaves me with 1x. So we know x equals 5. Now, to use that information to find NA, we know that NA is equal to the expression 7x minus 13. We're going to use this and we're going to plug in 5 for x. So we get 7 times 5 minus 13. 7 times 5 is 35. Minus 13, I get 22. Now in this next section, we're going to start to look at those special properties that the rectangle has separate from just a normal parallelogram. And the property we're going to look at is that the diagonals are congruent to each other. So in this first example, if I want to find FH, I know that FJ is 11. And I know that the diagonals bisect because that is a property of the parallelogram. So I know JH should also be 11. I now want to find the total from F to H. When we talk about total distance, even just the word total, what do you think of? You should hopefully start to think of addition. Total is the sum of the two distances. So FJ is 11, JH is 11, so FH is 11 plus 11, which is 22. So FH is 22. What is GJ? Well, I know that G to I, the other diagonal, must also equal 22. And I know that J bisects that line in half. So half of the line from G to J must be 11. All right, let's look at 14. So in number 14, I have JN, and I'm given KN. Now, we kind of saw this in the last one. Notice FJ was 11, JH was 11, and then we found GJ was 11. And we talked about this in the properties as well. When you have the pieces of the diagonals of a rectangle, since the diagonals bisect and the diagonals are congruent, that means that I get 4 congruent lengths. All 4 of the pieces are congruent. So here, JN is congruent to MN, is congruent to NK, is congruent to NL. And that's only for rectangles here. So now I know that JN is congruent to NK, therefore I can set their values equal. 5x minus 1 must equal 31. And I'm going to use this to solve for x. So to solve, the first thing I would do is add 1 to both sides. I get 5x equals 32. The next thing I would do is to divide by 5 on both sides. And when I do that, I get x equals 6.4. Now, I know we freak out sometimes when we get decimals, but do not fear. A decimal is not a wrong answer. It's just not the prettiest answer you could have. But it is correct. Now we want to find Jn. So we know that Jn is represented by the expression 5x minus 1. And we know that x is 6.4. So I'm going to plug that in here. When I plug that in, we're going to do 5 times 6.4. We get 32. Then 32 minus 1 is 31. So we know Jn is 31. And that matches what we would expect, right? Because Jn should be equal to Kn. All right, let's look at number 15. So in 15, we know all these pieces are congruent. So if I have some information about PT and TQ, I can use those to solve for x. So we know that PT should equal QT. I'm going to plug in what I know. PT is 2x plus 12. And QT is 4x plus 2. And now I'm going to solve for x by getting all of the x's to the same side. So I'm going to start by subtracting 2x. Why do you think I started there? Because 2x was smaller. So I get to keep positive numbers. So 2x minus 2x is 0. I'm going to bring down the 12. Equals 4x minus 2x is 2x. And I'll bring down the plus 2. The next thing I want to do is to get rid of that plus 2. Now we're solving for x. We're trying to get it by itself. And so I start to do order of operations in reverse. So I'm going to subtract 2 over first. I get 10 equals 2x. And then I'm going to divide both sides by 2. I get 5 equals x. So x is 5. Now we want to find PR. Notice PR is the entire diagonal. I do not have an expression for PR, so instead the first thing we need to do is find PT. So we know PT is equal to 2x plus 12. We know x is 5, so I'm going to plug that in. Now we get 2 times 5 plus 12. 2 times 5 is 10, plus 12 is 22. So I know this piece is 22. Well, because point T is the midpoint of PR, so it bisects that line segment into 2, I know that PT equals RT, and so this piece must also be 22. And now if I want to find the total distance of the line, I would sum those two together. So 22 plus 22 is 44. All right, now in this last section, we are going to look at the rhombus, or the plural of rhombus is rhombi. Kind of like a radius is radii. Rhombus, rhombi. Now, the property that we're going to use here is that the diagonals are perpendicular. So I'm looking for the measure of angle ABC. Here's A, trace to point B, and trace to point C. What is this angle right here? Well, again, the property we're using is that the diagonals are perpendicular. So what does that mean? Perpendicular means that they meet at a 90-degree angle. So all of these angles are right angles, which are 90 degrees. All right, number 17 says triangle RUN, triangle run. So R is here, U is here, N is down here. Connect to my triangle, there we go. Is a blank triangle. What type of triangle is this? Well, think about the property we're using, right? Because it's a rhombus, its diagonals are perpendicular, so we have a right angle. So this is a right triangle. Since it's a right triangle, we use the blank theorem. What theorem did we just learn? That would be the Pythagorean theorem. And we know Pythagorean theorem states a squared plus b squared equals c squared. We're going to use that to solve for Rn. Now, when we do the Pythagorean theorem, there are steps that we follow. The very first thing that we always must do is to determine which side is c, because c is the important one. It is the hypotenuse. So remember, the hypotenuse is always the side that is across from the right angle. It is the only side that does not touch the right angle. Notice these other two touch that right angle. So Rn is our C. Now the two legs, we could label either as A and B. Now the next step that we want to do is to plug in what we know to the Pythagorean theorem. So we know A is 3, so now I'm going to plug that in. We get 3 squared. Plus, we know B is 4, so 4 squared. Equals C is what we're trying to solve for, so we'll leave it C squared. And so now we're going to solve this starting by simplifying. So 3 squared we know is 9, right? 3 times 3 is 9. 4 squared, or 4 times 4, we get 16. And that's equal to c squared. Now we're going to combine those. 9 plus 16 is 25 equals c squared. Now, how do I get rid of the squared? What is the inverse of raising something to the second power? The inverse would be to square root. So when I square root 25, I get 5. When I square root c squared, we're left with c. So we found that c equals 5. And we know Rn was what we had labeled as C, so Rn equals 5.